In this short video I'm going to review some of the basics of integrals and differentials. Just start by reviewing the notation. If we have the derivative of some function capital F is some different function little f, then this thing is saying exactly the same as if we go the integral of this gives me capital F plus a constant of integration. So these two statements are saying exactly the same thing. The d over dx at the front is saying to differentiate this with respect to x as a variable, and the dx at the end is saying to integrate this with respect to x as a variable. So really, we're quite familiar with this from our, most people start with derivative calculus, differential calculus. We're quite familiar with this idea, and if we're happy with this, this is really just saying the same thing, but in a different way. Starting with this, we find the antiderivative, or the integral, plus a constant of integration. So let's take some examples. We all know that the derivative of x is 1. So what we're really saying is the integral of this is x. The integral of 1 with respect to variable x is x plus c. We can quickly figure it out. If we take the derivative of this, we should get this as the answer. Derivative of x is 1, just like we thought. Now let's do the next one. We're probably quite happy with the rule derivative of x to the power n equals. Now we would move the n to the front. We would multiply by x with a power less than 1, n minus 1. If we want to write this in integral form, we want to say the integral of this thing becomes this. Integral of this thing, n x to the n minus 1, becomes this, x to the power n plus our constant of integration. Now let's see, if we took the derivative of this, what would we get? Well, we would get the n would move to the front and the power would reduce by 1. It's really all there is to it. If you know a derivative rule, you can write the equivalent integral rule. Let's do another. What if we had derivative with respect to x of x to the n plus 1 over n plus 1. Remember, derivative. The power moves to the front. I just happen to have written the same thing, so they'd cancel. And then we reduce that, so it would be x to the power of n. Equivalent integral form of this, integral of x to the n equals this thing, x to the n plus 1 over n plus 1 plus a constant of integration. Now really these two are the same rule. They're the integral of x to some power. This is the way we normally remember it for integrals. So we say we increase the power by 1 and divide by the new power. These two are really the same. What are some other common ones? Some common derivatives. Well, you probably know the derivative of sine x is cosine x. So the integral of this bit, cosine, better put a variable x in there, the integral of cosine x with respect to x, it's this, sine x plus a constant of integration. You probably remember the derivative of cosine x is negative sine x. Now, normally, let's just introduce this to be a negative so we see that this would be a positive. So let's do the integral of sine x dx. That would equal this, negative cosine x plus our constant of integration. What other ones do we know? What other derivatives do you know? You probably know that the derivative with respect to x of e to the power x is e to the power x. So the integral of this piece, e to the x, equals e to the x. This is why mathematicians love the number e so much, because integrals and derivatives are so straightforward. That's another one. You probably know that the derivative with respect to x of the natural log of x is 1 over x. So the integral of 1 over x dx is ln of x plus a constant of integration. Are there any others that you need to know? I think that's the basics. Now, there's a few integral rules, I suppose, that you probably want to remember, and that's this. If we have the integral of some constant k multiplied by a function of x with respect to x, the constant can pop to the front, and it's k times the integral of f of x dx. That's a handy one to know. So pretty much any of these things we had here, we could have had some constant tucked in here, and it just becomes the constant multiplied by these results. What about if we had the integral of some function f of x plus a different function g of x, put some square brackets, all of those are being integrated with respect to x, then it's the integral of the first bit, integral of f of x with respect to x, plus the integral of the second bit, g of x with respect to x. We had a similar thing with derivatives, where we could take derivative of each term bit by bit. Each of these, as you take derivatives, take the integrals, you have constants of integration, of course. And this also works if it's negative, if it's this minus this. I won't write that down as a separate rule, but add or subtract, and you add or subtract the parts when you take integrals. So that's a very brief review. Your teacher will make sure that if there's extras, there's plenty of extras. I've just covered some of the basics, but your teacher will make sure if there's others that you need to know. And don't forget to check your textbook, of course.